Guys, hello and welcome again to the CMAX Silent Theater. Now this is the home of Cisco Live's Innovative Showcases. Now Innovative Showcases offers a look at the latest innovation from Cisco, not only giving the context but also the inspiration to today's IT professionals so they can create the world of tomorrow. Now today we'll be exploring the world of APIs. And to tell us all about the rise of the network APIs, please welcome to stage Susie Wee.
Hi there. Good afternoon. So thank you everybody for coming to our talk this afternoon. What I wanted to talk about is a really important trend that's in front of us in the industry. And this new trend is the rise of the network API. And also I want to take a minute to first thank all of you, because all of you have been critical in the networks and the infrastructure that are driving the applications in the world today. All of you have built your businesses or are running your businesses, deploying and managing these infrastructures and really making sure that these vast applications that are working on our networks are working well, working at higher and higher bandwidths, handling cloud applications and everything. And just thank you for being a partner as you've built everything that you have enabled today. But the important thing now is how we go forward together in light of this industry transition, where we have a whole new world where the network becomes programmable and the network has APIs. The thing that we know is that applications and APIs are transforming our daily lives. So we all have mobile devices, we all have systems that we're using every single day in our daily lives. These applications are not just for the privileged ones or just for techies. It's really impacting our daily lives. And the thing is that with the emergence of the cloud and so many wide-scale, worldwide applications, with the emergence of the Internet of Things, with higher and higher bandwidth needs like augmented and virtual reality and analytics, what's happening is the new set of applications need the network more than ever before. These networks require bandwidth, they need security, they need performance. They really need that network. And now the fact that that network has APIs represents a big shift and a big opportunity for everybody. And so if you take a look at all of the excitement that we experience through applications, through devices, and through the cloud, really what's needed below that is a very strong fabric, which is the network, and a fabric that has networking and has security built into it. And this is the infrastructure that all of you are building, deploying, managing, operating, servicing, and this is where the big opportunity is in front of us. Now to date, let's take a look at what's happened with applications and infrastructure. To date, they've been separate. We've had the folks who are building their applications work on their applications and build the best applications they can. We have the folks who are building infrastructure, the compute and the networking infrastructure, build the best infrastructure that they can. And they've really been treated separately. But then things have changed because the world of cloud has emerged, and that infrastructure is not just an on-prem infrastructure, it's a cloud infrastructure. And with cloud applications, the thing that's come into play is the whole world of DevOps, where as new applications are coming out, new applications are being deployed, there's expectations of CI/CD pipelines, continuous integration and delivery, and all of a sudden the way that we deploy apps on the infrastructure is more dynamic than ever before, and this new area of DevOps is really the expectation in that space. But something is changing. With all of the announcement that you've seen Cisco make, and just what we're doing in the industry, is that that infrastructure is now becoming programmable. The infrastructure is programmable. The infrastructure has APIs. And when that infrastructure has APIs, then the modern applications suddenly can interact with the programmable infrastructure in an entirely new way. They don't have to be separate. There can actually be benefit that those applications can have on a programmable infrastructure. And some of us are used to that idea for compute. As you're deploying a cloud application, you can spin up the compute resources that you need. But the other thing that's happening is that the network is becoming programmable. So suddenly, the network is programmable, there's APIs into the network, and modern applications can now interact with the network in an interesting way. And then there's an emergence of this new area where before we said DevOps, but now we can look at net DevOps. And this is an area where we're actually applying these DevOps principles to the network and looking at how we actually manage and deploy and run our networks, and to use a software programmable infrastructure using net DevOps techniques, and we'll be talking more about that today. So we've been going around the world talking to application developers and saying to application developers, we know that you've been building your applications, but did you know that the network has APIs? And they don't know. This is really new. And we're telling app developers, these are some of the things that the network APIs allow you to do. The network is actually programmable. And these are the 5 areas, or 5 of the key areas, where network APIs can help applications. And this is why app developers should care about network APIs. And for those of you who are running infrastructures, this is why infrastructure developers should care about APIs as well, since the whole possibility and opportunity is to help those applications work really well on that infrastructure. So let me walk through some of these now. So at a very simple level is the area of network performance, or I should say application performance. How many of you have used your mobile devices and have gotten a poor connection? Who's gotten a poor connection? Everybody. Why is that? The devices are amazing. The applications are amazing. Networks are amazing. But why do we get this poor connection? Actually, the reason we get the poor connection is because our applications are not talking to the network in a way that both are understood. And actually, there's a way that we can improve network performance for those applications. And it's actually quite simple. So simple it's embarrassing. It's to use quality of service. So we've actually teamed up with Apple, because Apple certainly has a lot of mobile developers as well as regular app developers. And what we did was team up with them to make sure that our developers could actually implement QoS properly. And what we've done is just had an SDK now where we actually ask the app developers to please mark your traffic. Mark your traffic. Which of the traffic in your application is best effort? Which is background? Which is interactive video? And which is interactive voice? Just mark it. Write your app as you would, but just mark your packets accordingly. And by doing that, we can ensure that the video and the voice get the performance they need, the background traffic can get what it needs. Just because now the application talks properly to the network. And let me show you a video of this. So on this video, what you see first is packets coming across. So as we start to surf the web, you start to get the browser that's creating network traffic, both best effort traffic and background traffic that's coming through. And this is coming through a Cisco fast lane network. Next, what we're going to do is make a video call. And as we make that video call, then all of a sudden you see voice and video coming through this application as well, or coming through this network as well. And what you see is that the voice traffic is prioritized the most, the video next. We turn the video off, so now you still see the voice coming through, and the best effort traffic keep coming through. So that's just a simple use of QoS, but we had to make sure to work with Apple so that QoS was implemented in the right way, that it could actually use what was implemented in the network. And so what we're seeing here is an example of what I said before, where now there's these iOS applications, iOS being Apple's operating system, and by properly marking these packets, then we can actually declare that as a fast lane iOS application that can work well on a fast lane network. And then what we do is we, again, offer developers, app developers, the opportunity to actually prioritize accordingly. Within DevNet, what we do is we have an offering which is fast lane validation. We will take a look at your mobile app, we will validate it, just to make sure you didn't mark everything as interactive voice. Make sure everything's marked properly, and then call that a fast lane validated network application. And then what happens, those of you who are running networks and infrastructure and building solutions, you can create solutions where you prioritize that data accordingly and provide the best performance that you can. A solutions provider could also decide which applications to prioritize, but also within that application, which data to prioritize. So that gives you a really interesting set of applications that you can run. And there's actually examples of this in stadiums and healthcare, augmented reality for retail, casinos and kiosks, all places where the network is really critical to application performance, where the network is stressed, and you can actually use this to optimize accordingly. Next, what I would like to talk about, another way that APIs in the network help going forward and help applications. It's the whole world of the digitized infrastructure. In the digitized infrastructure, apps connect people and data with places and things. This is actually a new breed of applications, and let's talk more about that. As all of you are taking buildings and digitally transforming buildings so that they actually have badging systems, vending machines, HVAC systems, security cameras, wireless, everything is getting digitized. And this creates lots of opportunities for app developers. So if we take a look at those apps, these apps are built in this way. You have your digitized infrastructure. There's data and information coming out of that digitized infrastructure. You want to run analytics and services on top, and then build applications that your end customers, your managers, your operators, that they can use. So as you put this together, let's just take a closer look. Now for the older applications that we built, you would have that same stack. There's a cloud infrastructure. That cloud infrastructure could be private, public clouds, on-prem, and so then that produces data and information. It could be a mixture of on-prem data and cloud data, on top of which you're doing data analytics, and then building your applications. But as we go into this new world, there's a whole set of places that are now digitized, where you have wireless networks that are providing capabilities like indoor location and proximity, on which you can do location and proximity analytics. You have cameras with video that are built into rooms where you can do video analytics on top of those. And then with the Internet of Things, you have a number of IoT devices that come into play that are producing IoT sensor data on which analytics can be performed on top. And then this creates a whole new paradigm of application development, and the network is what enables access and control and security as you're digitizing and connecting all of these things to create this new breed of applications. In addition, there's a new interface, a new way that people can interface with these applications through bots. So it's really interesting when you're starting to do the automation throughout the infrastructure, and as you're starting to create these applications, and humans can just interact by querying through a bot to get the information that they need. And so then Cisco has a number of products that help in this space, as we're talking about things like Cisco Spark, which looks at where applications meet people. We're looking at things like Meraki and CMX, which talks about where applications meet places, and Jasper, which helps where applications meet things. And in addition, we're excited because some of our newest collaboration systems are actually being digitized with APIs, and there's a new XAPI that's available, where what we can do is now program the room devices and the cameras. And they have things built in like video analytics to count how many people are in the video scene. And all of this can be in your application. So we've actually built a co-creation, a business application that we call Glance, where we've built a business application on the digitized infrastructure. And what it does is you can put in a map using CMX and Meraki. You can understand where are the different areas of a store. Where do we have electronics? Where do we have hardware? Where do we have different types of things, appliances? And then you can detect where there's hot spots of people, and as people are like queuing in an area or sitting in an area too long, send an expert to go and help them. So it's a very interesting way to bring together people, places, and things to create very interesting applications. Next is security. So let's look at the world of security. When we're looking at security, then we have a place where the network can provide security for your apps. When you talk to an app developer and you tell that app developer that, hey, did you know that, like right now for an app developer, you are responsible for doing your own security. You're responsible for keeping your customers' data secure. You're responsible for keeping your application secure. But did you know that the network can help you? That's such a burden for the app developer. They love it, knowing that the app can help. So there's an opportunity to have a secure programmable network where there's secure network devices, such as by using OpenDNS. By using OpenDNS in your browser, you just set your DNS over to look at an OpenDNS server. And by doing that, it can look for bad addresses every time you're making requests to fill out a web page. And if there's any malicious URL that's been inflicted, we can actually redirect that before it happens. And you're taking advantage of cloud-managed security. You're taking advantage of threat intelligence, because chances are someone else has hit that problem before you've hit it. And we can actually build that intelligence into the solution so that your application is automatically protected. And there's APIs into this where if you have security systems, you can actually query the security system to understand, has this URL been afflicted? Has there been any malicious use on this? If you face a bad link, you can actually send it in yourself and report it. So the fact that APIs are available for all of this are really an important thing. Next, what I would like to do is go into this world of net DevOps. So as I said before, in net DevOps, the network is now programmable. And because the network is programmable, what we can do is now treat the network as code. What does that mean? That means when you're managing thousands, tens of thousands of devices, instead of managing them as individual devices that you configure, you can actually treat them as a software system. Roll out software changes, pull back software changes. And that's what's enabled by this network programmability. And this gives you an ability to automate. You can put in automation so that you can scale your applications. You can actually scale your configuration changes. You can now optimize the performance of your applications by now taking the network into consideration. And then you can assure that you're getting the proper behavior from your network. And now to talk to you more about this and to show you a demo of it, I'd like to introduce Mandy Whaley, who's the Director of Developer Experience on DevNet.
Thank you, Susie.
Thank you, Mandy.
Thank you so much. So I'm excited to dive a little deeper into this concept of net DevOps. And I'm going to talk through what is it, what do we mean when we're talking about that, some examples of why it's needed, why this change is showing up in the industry, and then a demo that'll hopefully make it a little bit real, a little bit tangible for you. So the first reason that we really need this is we need to be able to quickly provision infrastructure. And historically, we've done this in a sequential and manual way, but that's not fast enough today. We've got to move to parallel and automated. The other reason that this is such a drive for this is that the realization that snowflakes, lots of individually configured and managed systems, slows us down. All of that system variation makes it hard to roll out changes. So we need to move from system variation to system consistency. And then the last thing that's really driving this is version-controlled infrastructure, and this is treating the network as code. Taking your network configuration files, and instead of have them being organically configured over time with lots of drift, moving to actually having infrastructure as code. And so what's exciting about this new area is that all of the APIs that Cisco is opening up on our network controllers, our network devices, that's part of what enables this, because now we can script these configurations. We can manage them in an automated way. And the other half of it is really the assurance, right? If you're automating at scale, you need lots of analytics and assurance to know that the right things are happening. And so that's really the things that are coming together, and we're seeing in DevNet as we bring application developers, ops engineers, network engineers together to work on really figuring out this practice of net DevOps. So I'd like to show you a demo. We're going to go to my screen now. I think, yep, ready? All right, so what I'm going to take you through is a demo of a simple network change. We have a task we need to add a VLAN. So this is kind of like the hello world of a network configuration, right? So we're starting in a Kanban board or an issue tracker or a ticket system with a task. Someone's asked to add a VLAN. And we can go into that since we're managing it in an actual version control system using Git. We can see where the engineers have collaborated on it, have made comments to each other about it and what they're doing. We can also connect this to Spark, so you can actually have these comments show up in your chat and notifications. The next thing that we would do from there is, this has been approved, yep, we want to do this. So this change actually gets merged in. And what we're looking at here is the actual file. So over here, it's the file that's doing the configuration of the devices before the change, and over here it's after. And if that looks familiar to you, that's great, but the main things to notice are the pluses over here, configuration information was added, things have been taken away and changed over here. And what happens is this is a diff between the file, this is merged into a branch, and then what kicks off is our network to code information. So we can see the history of all those changes that have been made, and this is something that application developers are very used to doing with their code, but it's new to network engineers for managing network configuration. So after it's merged into the branch, we're going to go through a couple stages in the pipeline. And so the first thing that happens is a stage where we just do some really simple analysis on that file to say, is the syntax right? Will the file parse and run correctly? Will Ansible be able to use that playbook? And that's this section. After we've done that, we are ready to actually deploy this to production. So to our test network, sorry. So what happens in this step is we have a test network. How many people have a full test network laying around to test changes on? Not that many, right? So what we've actually done here is we've simulated the test network. We're using a tool called Viral or Cisco Modeling Labs where we can build out our network as a model. And so we're using that as a test network. If you have a real network, you could do this step there as well. What happens here is an Ansible playbook runs, it takes all those configuration changes to implement that VLAN and goes out and pushes them to all the devices that are affected by the change. And then at that point, we have the changes in the network. We have them in our test network. But we don't know if they're doing what we expect. We don't know if they're actually working. We might have just really caused havoc in that network, right? It's our test network, we're testing something. And so what's new is we do have a way to test those changes. And this is a new project on DevNet called PyATS. We're really excited to bring it to our community. And it's a Python automation test framework. So you can write tests that looks at the desired behavior of the network and sees if it's behaving correctly. And you can see here we've run tests. You can see that the expected number of BGP neighbors is correct. And I can actually show you what that test looks like to set up. So just this one line of code, which is very English-like, is all you have to write to specify, I would like to check that behavior after my network changes. So this is a very cool tool. You can find it on developer.cisco.com. And it's really been a missing piece of bringing a build pipeline to network as code, is being able to write these tests and have a good way to deliver them. So I will end up there that we do have all of these demos running in the DevNet zone. You can come over and talk to the people that have been working on it and see them in action. And I can go back to my slide now that I will finish up just to kind of bring this back together. We can go one more forward. Oh, I can do that. Look at that. Slides is code. Okay, so this is a picture that I'd like for you to take away in your mind, and this was what we just walked through. So network configuration stored in source control, stored in Git. Then the changes are proposed in code. They're merged in through a branch. Then a build server kicks off, we deploy, we test. If everything looks good, we can schedule a deployment to production. If things are not so good, we start that cycle over again. We make more changes, we deploy and test. And once again, this is something we do with our applications, and now we're bringing that DevOps practice to the actual management of the network devices. So I'm going to end there and give it back to Susie, but do come see us in the DevNet zone and check it out. Thank you very much.
Thanks, Betty.
Thank you. Great, thank you.
So you can see that that's very compelling and shows how we can take our networks, operate our network as code, and take advantage of this new area of net DevOps. Now, the last area that we want to talk about is something that we call is multi-cloud. So as we know, applications are moving to cloud applications and hybrid cloud, but more often than not, we're now seeing multi-cloud applications. We've actually seen this in our own DevNet production environment. So DevNet also has a portal, it has a sandbox, it has learning labs, we run events, So we actually run a cloud system ourselves. The way that we were is that some of our different services were actually running in different places. Some were running on GCP Cloud and Google, sometimes we're running on AWS Cloud, and some were on-prem, like our sandbox, where we needed it on-prem and we needed hardware to be in there as well. So as we get to the next level where we're integrating more of these services together, we actually do have a multi-cloud infrastructure. And what I would like to do now is introduce our speaker from Google, who is going to be telling us about Istio, which is helping developers to actually work in this kind of a multi-cloud environment. Jerry Forochev is the senior product manager, Jersey is the senior product manager of GKE and Kubernetes. And he's probably the only person I know who has a PhD in physics, a master's in computer technologies, and an MBA all together, and is now working in software. Welcome, Jersey.
Thank you.
Thank you.
All right, so I'm going to do is, how do I do it? All right, I'm going to tell you a little bit about the service mesh. So a couple of years ago, probably around 4, there was this big hype of splitting all the monoliths into microservices and then containerizing them and then using Kubernetes. This became the thing, right, in the industry. So obviously, well, I don't have to tell you about the microservices. You just break the monolith, you take them apart, you put them in separate containers, and you take it from there, right? Luckily, well, you have Kubernetes to orchestrate it because, well, you have many instances of your applications and various components now, so you have to find a way to deploy it, which is probably similar to what you just explained, a CI/CD system. And then you have to find a way to actually particularly put it onto your computers to run, right? You have to figure out a system that would make sure that they're actually working, that you have the proper utilization of your resources, that they're resilient, and so on. Luckily, all of that is done by Kubernetes. It is a thing, right? You just use it. It's a solved problem for several years now. You just specify where is your container, how many replicas of it you want, and then you submit a config file into repository, submit a container image into repository. A config file gets uploaded to Kubernetes master. Kubernetes master is consulting with the scheduler. Scheduler figures out where to place it into your underlying physical infrastructure, cloud infrastructure, finds a proper place with the right amount of resources, and then deploys the container. Container gets there, gets deployed, gets maintained, right? Gets restored when it doesn't work, and so on. So really, literally a solved problem. Now, the big question comes, and this is why I'm here, how do you make sure that now all of the services can talk to one another, right? Because, well, right now, you have a situation where they're all taken apart. They're not communicating in memory, right? You have to figure out how to load balance if you have multiple instances of the services. You have to make sure that there is a fault tolerance, right? That someone is actually recreating the request if there is no response, right? And you have to get some level of observability to make sure you can actually tune it and get the performance you want. Right? So imagine for a while you're in the Java world, right? You have all of these tools that you can use to get what I just described, right? So you have to get the service registry, you have to do the client-side load balancing, you have to do all kinds of tracking, monitoring, data visualization. So you end up having your microservice surrounded by the array of various tools, and all of it is non-functional. Your application is just there, but it needs all of that to actually work, right? This is wrong, because at the end of the day, what you really care for is the communication between microservice A talking to microservice B, preferably over HTTP requests. That's all you need, right? You shouldn't be worried about all of these other parts. Well, Istio comes to help. Istio is a service mesh. Istio is a fabric for service-to-service communication. It's an open source project. It was created primarily in the collaboration between Google, IBM, and Lyft. with many, many others contributing. It literally takes care about how the services talk to one another. Just like Kubernetes takes care for deploying your workloads and making sure that they're working, here you have a fabric that provides resiliency to the communication. So in a way, you're abstracting your application from your ability to change the behavior of the service, right, independently. So in a way, you can say, well, just like you had Kubernetes with its control plane, right? You have another control plane that is now doing the service-to-service communication, management, all kind of routing, and then performance monitoring and tracing. All of it is there, right? So from this, you can now go back to this, right? So you basically have a microservice, and now you have a proxy, right? We call this a sidecar. And the proxy of a choice is Envoy. Envoy has been primarily, it's an open source project again. It has been primarily created by Lyft. And it's been heavily tested in production environments. It's a beautiful proxy. You should check it on your own. It has all beautiful features it should have. The interesting information about Istio is, well, you can and should use this proxy, but if you want to use a different one, you can, right? So once you have it, now you have a system where you really rely on like proxy-to-proxy communication. So every microservice has its own proxy, and all pieces of communication happen through that proxy, right? And on the side, you have a pilot which is keeping a configuration of your entire network. You have a mixer that deals with the policy, and you have auth to make sure that you deliver the certificate. So let me walk you through a very simple request, right? So imagine you have a service B, which is your server. Now you're deploying service A, right? Service A comes up, then the proxy fetches information from the pilot on anything related to routing, configuration, etc. And then it fetches certificates from the auth, right? And now the service A places a request to service B. So what happens, right? It gets intercepted by the proxy, and then the proxy consults with the config file that it's fetched from pilot, right? It's like, you know, where should it really route it and which way, right? So it chooses a protocol that the other party understands, and it calls up service B. Well, this gets intercepted by a proxy of the service B that now is consulting the policies, the ACL, the quota, whatever you want, with the mixer, right? That has modules where you can configure all of it. Once this is confirmed, the proxy is now forwarding this request to service B. Service B responds, gets forwarded back to service A, intercepted again, and then forwarded further. Now what happened in between is both proxies are reporting back into the mixer, right? Which is like, you know, all kinds of logging and monitoring. And through this, you can really get the client perceived latency and all the ways of optimizing your entire system to maximum performance. And that's, ladies and gentlemen, Istio. That gets you visibility, resiliency, traffic control, security, and policy enforcement. You're full set for managing service-to-service communication. So that's at the core of what we're doing, and that's at the core of being able to now serve systems that are cross-connecting different clouds, because this is an open standard. It's primarily done for Kubernetes, but talks to anyone. Thank you.
Thank you. That's a great example to show what application developers have to worry about when building out their new applications using containers and microservices, the newest tools like Kubernetes. And Istio is there to help, and Cisco is very happy to be teaming up with Istio, with Google on this, as we're building out these tools. And as we said, our system in DevNet is actually built using these types of tools today, and there are problems that we face and opportunities that we have. And what I'm hoping is that all of you who maybe you work in these application space and you actually face these problems every day, or maybe you haven't had such a walkthrough like this, but you're actually running the network infrastructures. But I think that what that example showed is you could probably infer the dependencies of the applications and the microservices and containers on the network and the places that the infrastructures that you're building can actually help applications. And that's the opportunity that's in front of us. So what we have is we have on DevNet a Cisco and Google Cloud Developer Center where you can go and get training in these different areas. And we also have in our DevNet sandbox a setup where we actually have Istio set up where you can actually reserve some time, go into the sandbox and get started using these tools instantly. So we talked about a lot of really interesting areas right now. We talked about a new paradigm in which applications depend upon the infrastructure in entirely new ways, and there's entirely new opportunities because of the programmability of the infrastructure. But what does this mean for all of you? So all of you are working in different spaces, and it might seem far away, it might seem close, but DevNet is here. Our pure mission is to help you be prepared for this space and to evolve you from where you are today to being able to embrace these opportunities in front of us. So DevNet our goal is to catalyze your innovation, to provide you with the tools you need to learn, the tools you need to code, to give you inspiration for new areas like the areas we discussed today, and to give you the community in which you can connect. And DevNet is a way that we can help you with your innovations. So what I'm going to do is just go through a lightning round of some of the new offerings that we have on DevNet, and there's many more, just to tell you the tools that are available to you. So first of all, there's a new video series on network programmability. So Hank Preston, who many of you know, has been creating these video series for you to use. So you can have one video series each day as you're having your breakfast and enjoy this. Also, Wendell Odom is someone who's provided a lot of training for our networking community. And we have Wendell Odom who's actually come and built some DevNet learning labs. And we released some new DevNet learning labs on how to build your home networking lab for network programmability. So all the learning that you've done today to networking, you can now learn about also with network programmability. Mandy talked about NetDevOps and a really important tool, PyATS, the Python Automation Test Systems. We just onboarded that onto DevNet, so this is a resource that you can go to actually pick up and learn and actually use this environment today, and that's a huge enabler for this new world of NetDevOps. Something that we've done for the first time is we are actually working with different countries, but for the first time we've created a DevNet Developer Center for a country, for Italy. And this was just released on Friday, last Friday. And so here what we're doing is we're actually showcasing some of the innovations that are built by some of our partners in Italy. And we'll look at more of these in more countries going forward. Next is, with DevNet, something that's very important to us is our network and infrastructure developer audience, but also the application developer audience. And something that we're doing on DevNet is actually building out an app developer zone, a space where app developers can go who understand iOS not as a network operating system, but as a mobile operating system. So we actually have many different types of tools like providing location services to your users, maximizing network performance on iOS apps, mobile iOS. And so you can see that there's actually many new resources that we've put out for application developers who are learning to use our different resources. And one example is that we have many of these coding nuggets. You can get started right away and start coding and do things like create a conversational bot, and we walk you through so that you can actually create these quickly and easily. And then in the DevNet zone, something new that we've done now is that we're actually incorporating design thinking. So we've been doing a lot to provide you enablement on the technical side for coding, but what we also think is really important is to understand your problem, to understand your users as you're building your solution. So design thinking is a new area that we have in the DevNet zone. And next is we've been building out the tools for a developer ecosystem so that creators, developers can write code and consumers can use this code, and you can build on each other on top of Cisco platforms. In addition, what we're doing now is raising up to enable the business ecosystem, because many of our developers, our creators, want to become sellers of their code. Those who are consuming want to become buyers of code, and enabling this business ecosystem is key. And what we've done is we're offering a new DevNet Solutions Plus program, where ISVs who've written software solutions using our APIs, for some select cases, we can actually put them together on Cisco's price list so our partners can actually build solutions and our customers can buy solutions that involve this ISV software that's written by our developers on top of and together with Cisco Kit and Cisco infrastructure. So these kind of combinations are really important for our users, and we've been validating these applications so that they work well in these solutions. So in summary, we've talked about the whole world of the programmable infrastructure and what that means for applications and how they can help each other going forward and not just be separate. We talked about why developers care about network APIs, and it was in all those ways. So just the final note is I just want to reiterate that applications need the network more than ever before. And for all of you, you are a developer. As you're building out your networks are big software systems that you need to run as code. You may not be coding thousands of lines of code each night, but you need to control big software users and become power users of software. You are a developer, and the network is your innovation platform on which you can really build your opportunities going forward. Thank you very much.